What's your answer, Ra?
1 minute, ma'am.
Hmm.
Ma'am, is it option A, ma'am?
How come? You are having ethyl magnesium bromide. You want to prepare ethane from it. So first write down the compound here. This is minus and plus. So in order to make it ethane, I just need H plus here. Which among the following will give you the H plus here?
Option C, ma'am.
The C minus and H plus, isn't it? Yes
Yes,
or
ma'am.
no? So this would be the one which supply this. So whenever you see a Grignard reagent is there, where the R part of the Grignard reagent is just getting added with an plus H, go for acidic hydrogen supply. Here, this would propine is having acidic hydrogen, so it will supply the H plus here. Okay.
Yes, ma'am. Ma'am,
Hmm.
like what would happen if you react with aldehyde or ketone, ma'am? I forgot. Uh,
When you react with an aldehyde, you get a secondary alcohol.
got it, ma'am.
MgBr is there. This is plus, this is minus. Goes and attacks, shifts. CH3, CO minus, H, C2H5. Then hydrolysis happens. You get CH3, CHOH, C2H5. This is for aldehyde. If I reacted with a ketone, you get tertiary alcohol. If I also reacted with esters, you get tertiary alcohols.
Got it, ma'am. Yes.
Next question, Mithul. Which will not be shown by C4H8.
Ma'am,
Hmm.
it will show
Hmm.
structural isomerism, and chain isomerism,
Hmm.
uh, even positional isomerism will be shown.
Okay.
Geometrical isomerism will also be shown, ma'am. So I think B won't be shown.
Don't please say I think it is. It cannot show metamerism. C4H8 can be written like this, can also be written like this, isn't it? So as you said, they are showing positional isomerism. Also, they can say geometrical isomerism because of the cis trans configuration. Geometrical is also possible. What about chain isomerism? Where do they call this chain here? What is chain isomerism, Prof?
Different structural
Yes,
formulas,
like
ma'am.
this it is, isn't it?
Yes, ma'am.
Not linear, but chain it is. Can it also chain ring chain isomerism? Ring cyclic?
Uh, but this,
Yeah, it
I
can
don't
show,
think so,
isn't
ma'am.
it? Why you don't think so? Won't it show cyclic isomerism?
Oh, okay. Ma'am, I thought cyclic means they should be interconnected, ma'am. Every carbon should be interconnected.
No, no,
That's why.
not like that. Here it is. Huh? Here they can go for a cyclic isomerism, right? So metamerism cannot be shown. We know what is metamerism. What is metamerism? Push of a CH2 group across the functional group is going to create a different chain, but still the same functionality is remaining. Then that is metamerism. Okay.
Yes, ma'am.
Right. Arun,
Yes, ma'am.
you just tell me the steps. You will not go for the calculations here.
Yes, ma'am. First,
Mm,
we shall find the
mm.
equivalence of PbNO3 twice and Ki solution, ma'am.
Okay.
By finding, we would get some difference in equivalent. Sorry, ma'am. Equivalence, I guess, ma'am. Like molality into volume into n factor would be the equivalence, ma'am.
Mm,
So we would be getting 1 minute, ma'am. Ma'am, first we can find the number of moles of PbNO3 twice, ma'am, and
Correct.
number of moles of Ki solution.
Okay.
And we can write the equation of this reaction, ma'am. PbNO3
Okay.
twice plus
Mm.
Ki gives you PbI2, ma'am.
Very good. So I can understand
PB
there's 2 moles which is
2.
required here, right? So the
Yes,
reactant
ma'am.
1:2 part. So if 40
Yes, ma'am.
is there, 40 would have required how much?
80
Only 80
Ki, ma'am.
millimoles. But how much is here? 90. So this is excess reagent. Then who is the limiting reagent? PbNO3
PbNO3.
twice. So that will be the one which is going to form PbI2. Correct? What
Yes,
proportion
ma'am.
are they? 1:1. So it should be also 40 millimoles.
Yes, ma'am.
So that is your precipitate here, PbI2. It's asking you what mass will be formed. We know moles multiplied by molecular weight give you the weight of it. 40 into 10
40.
power minus 3 into PbI2 is molar mass. They are providing you here.
Yes, ma'am.
207 plus 127 into 2.
Got it.
Mithul, did you understand, Pa?
Yes, ma'am.
So we are using the limiting reagent concept here. So for that, calculate the millimoles at first and write your reaction. Look at the proportionality in which they are participating here and then go for the reaction. Yes. Mithul, your question.
Yes, ma'am.
This time there were not many questions from atomic structure. For sure shot, you can expect in shift 2 questions from atomic structure.
Ma'am, I think answers option C. I know option C is incorrect, ma'am. 3p orbital has 2 nodes, no, ma'am.
How come?
Oh, no, ma'am, no, it's correct only, ma'am. Sorry, ma'am.
Hmm. Okay, let's make it faster, right? When the first trick is that whenever you are given lengthy statements, look at option 1 and 4. Most of your answers will be there. I look at option 1 here. The 4 lobes of dx square minus y square are along x and y axis, where the lobes of dxy is at 45 angle to x. Yes, this is right. So dx square minus y square here, you will be having two nodal planes, each at 45 degree to each other. So here they are mentioning they are present at 45 degree to each other. That's right. This is a factual question. So if this is correct, then go for the last statement. The maximum probability of finding the pz electron is maximum along x and y axis, while dz square is maximum on the z square axis. For dz square, yes, I accept. This is correct. This is how the dz square is this, right?
Yes.
Now let us consider the second statement, first statement here. This is they are talking about the pz, and they say the maximum probability is along x and y axis. We know for the p orbital, the nodal plane is present in the one not mentioned in the orbital, atomic orbital. Here I said pz. So where will there be no electron distribution? In px and pa only. X and y axis only, there will be no electron distribution. But they say it is maximum along x and y axis. So it is false. What about dz square? Ma'am, does it mean only in z square it is available? No. You can see there is a donut that is available along z also, xy plane also. That's the reason that you say the nodal plane for dz square is 0. You can find it is equivalently present in x, y, and z axis. So therefore, this statement is wrong. Understood? Look at the so
Yes.
this is the incorrect statement here. Look at the second one. The orbital angular momentum, yes, it is provided by this formula, square root of L into L plus 1 h by 2 pi. And it is the same for 3D and 4D. That's true only. Because L value for 3D and 4D is the same. Then it will be the same only.
Yes,
This is
ma'am.
correct. A 3p orbital is having one radial node. Of course, I have 2p and 3p only. So 1 radial node it is having. While 4F will have 0 radial nodes. That is also correct. There is no 3F at all. So directly it is 4F only. So this is
Yes,
also
ma'am.
correct. Mithul, no,
Ma'am,
Tarun.
4 is correct, ma'am. So 4 must
Okay.
be in the option.
Mm.
1 and 2. Ma'am, can you help me with 1 and 2 alone, ma'am?
Adenine and guanine are substituted pyrimidine. Is this right? Are they pyrimidines, first of all?
No, ma'am.
Then what are they? Purines. Right now.
Yes, ma'am. So
Mm.
2 and 4.
So I have told you one shortcut to remember this. Cute pi. Cytosine, uracil, thymine are pyrimidines here. Gap. Guanine, adenine are purines here. Correct?
Yes, ma'am. Yes.
Hmm? Then what about a fourth statement here? They are mentioning what kind of bond they are mentioning there. Are they mentioning glycosidic bonds here? Is a glycosidic bond that is present in protein?
No, ma'am. It's
Peptide bond, na?
peptide bonds.
You
Yes.
would have read glycosidic bonds only in carbohydrates. So this is wrong. This is also wrong. So 1 and 4 are wrong. Then option 2 and 3 should be right here.
Got it, ma'am.
So now, since you know, got to know the 2 and 3 are right, let's see what is 2 and 3. The sugar moiety in RNA is beta D ribose. That is correct. And DNA is beta D 2 deoxyribose. So this is correct. So 2 is correct. Third option. In polynucleotide chain, a phosphate moiety links the third carbon of one sugar to the fifth carbon. That is also correct. Read it one more time for yourself. They didn't ask you about the Zwitter ions also this time, and not much from the interior of biomolecules. Very easy questions were there. Understood by these 2 points?
Yes, ma'am. Yes, ma'am.
Yes. And remember, this phosphide moiety that they are talking is about phosphodiester linkage. So if they're asking for phosphodiester linkage, again you should say the same thing. Third and 5 carbon of the sugars are being reacting there. Okay. Right. Next one, Mithul.
Elimination reaction, ma'am.
Right. It's the elimination reaction. Do you guys need one more recap of elimination types? Even
Yes,
E2,
ma'am.
even CB?
Um,
Maybe Tarun, you were about to say something.
no, you taught us in that last class.
He wants us to do it. E1 reaction is just like your SN1 reaction, which happens by 2 steps here. E2 is concerted, like your SN2. There is no 2 steps here, only one single step. Here also it is happening by 2 steps here. E1 reaction, like SN1, this also goes with carbonium stability. Like SN2, there is no intermediate. E1 CB, the word CB stands for conjugate base here. So it means it is moving by a carbanion as an intermediate here. Okay. So when I'm talking about this E1 mechanism, the very important thing is that they should be having more plus I effects. In other words, I'll say they are sterically surrounded by the plus I effect here in order to eliminate them. But here, there should be no steric hindrance here. For even, I am not bothered about having stronger bases. Even weak base can also do it. But here, the base should be stronger base. Okay. The next one here is that the stereochemistry that is involved in the E2 mechanism. The hydrogen and the leaving should be anti here. Here, there is no necessity for the stereochemistry. Right? Of course, I need good leaving groups here. Here also, I need good leaving groups for the formation, for the immediate, no intermediate step that is involved here. In even CB, the requirement is poor leaving group, like fluorine, like OH, poor leaving groups will be there. So that they are going across this benzene formation. Okay.
Yes,
So
ma'am.
we studied the energy profile diagram here, where this carbonium formation is the uh, hindered step here, RDS here. This is my RDS followed by the second step. Here one single step. Here carbanion, sorry, I reverse the step. Carbonium is the RDS, it will be having higher energy followed here. Here the second step, the leaving group removal is the hindered step here. This is your about your E1, E2, E1, CB. Understood, Ada? Mithul?
Yes, ma'am.
Okay, go for the next question. Tarun?
Yes, ma'am.
Just tell me the steps.
Yes, ma'am. Ma'am, like let us take 1,000 grams of water, ma'am. So number of moles of glucose by number of moles of glucose plus 55.5 is equal to 0.05, ma'am.
Why does so much
Since
calculations? They said mole fraction of glucose is 0.05. That means moles of glucose also is 0.05. And what will be the moles of water here? 0.95?
0.95, ma'am.
That's it over, na? So you got the moles, molality is moles, so it's 0.05 divided by weight of solvent in kgs. I have 0.95, so I have to multiply by 18 into 10 power minus 3. Okay.
Got it, ma'am.
So what is the key point here? Whenever people are talking about mole fraction is nothing but equal to moles itself. So once I find 0.05 is the moles of glucose, the remaining moles will be of water. Because we
Got
know
it.
mole fraction of xA plus xB is equal to 1.
Yes, ma'am.
Right? And please remember molality is independent of temperature here. Next one, Tarun. Mithul.
Mom, 1 minute, mom. I just want to refer to one thing, mom. I want to answer this question.
Okay.
It is n is equal to 2 to n is equal to 1, mom.
Why?
Mom, E is equal to 13.6 into 1 by n1 square minus 1 by n2 square, mom.
Okay. The question is
I
asking
just
for
calculated it.
maximum wavelength. That means the energy should be the
Oh,
least here.
Okay, ma'am. I think it should be opposite.
Ah, answer is 6 to 5. We know that
Ah,
energy
yes, ma'am.
decreases as the n value increases. If I say energy is decreasing, then the lambda should be more,
Ah, yes, ma'am. Yes, ma'am. That's
right?
what, ma'am. I messed up.
Understood, Tarun?
Yes, ma'am. I got it, ma'am.
Okay, okay. And I hope you remember the number of transitions, how to calculate the number of transitions as well.
So n2 minus n1 into
Uh,
n2 minus n1 plus 1 divided by
plus
2.
1 divided by 2, number of transitions. Tarun.
Delta G is equal to delta H minus T delta S.
Okay. Hmm.
After this, we'll be getting
They are asking at temperature 200. You have provided delta S value at 200. Okay. So minus 200 into minus 180. This part you are having already. But you have to calculate delta H not at 200. You have provided delta H not at 400 only.
um, 1 minute, ma'am.
Hmm. The clue lies here.
Uh, Delta H is equal to NCP delta T, ma'am.
Okay. Delta H is equal to delta
Delta
Cp
NGCP.
delta NGY.
Yes, ma'am. Yes, ma'am.
Delta Cp dt here, right? So the delta H means between the two different temperatures. Delta T is between the two different temperatures. You are asked
Yes,
to
ma'am.
calculate for 200. 400 is provided to you. So just write it. Delta H 400 minus delta H 200 is equal to delta Cp. Temperature difference is 400 minus 200. Substitute the values to get this value and substitute it here.
Got it, ma'am. Yes. I was confused with delta H
Ah,
200.
okay, no problem. Okay, wow.
Yes, ma'am.
Ma'am, can you tell me the name of the compound, ma'am, at the reactant, ma'am?
Which one? This one.
Yes, ma'am. The compound name alone I want, ma'am. One second, ma'am.
You can either call it as 3-amino nitrobenzene or 3-nitroaniline. Usually, whenever you are having the common name for the benzene compound, go for it. 1, 2, 3. So I called as 3-nitroaniline.
I think the first one itself we can use, no, ma'am.
Correct. First one.
It
What
will,
will happen when you use this?
you'll get N2Cl,
N2Cl.
ma'am.
Now with
Sorry.
H3PO2, acid. Correct.
Uh,
Hmm.
NO2, N2Cl. Ma'am, am I right?
Yeah,
Cl.
NO2 will exist. That's right. NH2 gets
Ma'am,
converted into N2Cl.
yes, ma'am.
Hmm.
I
Then
couldn't
when you
hear you
are
in the middle. That's why, ma'am. Sorry, ma'am.
okay, so when you use an acid, what will happen? N2Cl gets hydrogenated, so you just have hydrogen here.
Yes, ma'am.
Okay. So N2 plus Cl minus, when you're using with an acid or an alcohol, you will get just benzene here. And then you treat it with water here, steam, then you'll get OH, phenol. Okay, fine. If I'm going to have two nitros here, I want to convert it into this. What reagent will you use?
Ma'am,
Hmm. Hello? Can you hear me, Da? Can you hear me, Mitul? Tarun? Can you hear me, Pa?
yes, ma'am.
Yes. What reagent will you use here?
Ma'am, any reducing agent, ma'am?
I'm having two nitros, Da. I'm selectively reducing only one nitro here. Any
Yes,
reducing
ma'am.
agent will reduce both, na? You will use ammonium disulfide. NH4 twice, which is a selective reducing agent. Only one will be reduced. Okay.
Yes, ma'am.
What shall we do here? The O2 is the initial pressure was 400. After 20 seconds, total pressure of the gaseous mixture increased to 700. So what should you do?
400 minus
Minus
2x
2P,
plus 4p
4P,
plus p
P.
is equal
Very good.
to
Very good.
700, ma'am.
700. So what is your P value then?
100.
100. Very good. They're asking you for the average rate of reaction. How do you write average rate? Like this. Correct, na? Like this you write
Yes,
it,
ma'am.
isn't it? So I can go with anything, either this or this. So what is N2O5 rate of deformation of the N2O5 here? 200.
200. Yes,
Right.
ma'am.
So 1 by 2 into 200 divided by 20.
5 will be
5.
done.
Both of you, Mithul, did you understand, Pa?
Yes, ma'am.
The question is connecting between equilibrium and kinetics here. So step 1, it's easy for us. But step 2, we have to understand what is this average rate. Average rate is nothing but the relative rate here. So what is the rate of disappearance of N25 or rate of appearance of O2? Anything we can take here. Okay. Either you do 100 by 20 here or you do this. Both are same. They are giving you at equilibrium concentrations of them. That means can I calculate
Ma'am,
Kc from
I
this?
would like to take 5 minutes, ma'am. I'm
Okay,
getting
da,
an
go on.
important
Go on.
call, ma'am.
Important call. Okay, go on.
Yes, ma'am. Physics, sir, ma'am. School, ma'am. He's
Okay,
calling
okay.
me.
Okay.
Ma'am, is it
Yes.
0.6, ma'am?
No, I don't know. I'm just check the answer. No, it's 0.5. Step 1, can we calculate the Kc here?
Yes, ma'am.
So it's 0.8 square divided by 0.4 square, isn't it? It's going to be 4 here, right?
Yes, ma'am.
Now
Ma'am,
they're telling, tell me.
but they didn't give the. Oh, okay, okay. Sorry, ma'am. You can
Uh,
continue.
if initially I had 1 mole of each, then what will be the alpha value here? So that means 1 minus x should have become a 2x here. Correct, na?
Yes, ma'am.
So
Yes,
it
ma'am.
is 2x square divided by 1 minus x the whole square should be equal to 4 again. Because Kc value is the given. From there, can't you calculate x value?
Yes, ma'am. Got it.
If not, you
Why
do by
can't
this
we
method.
equate
Tell me.
like 1 minus x is the equilibrium concentration, no, ma'am?
Yes,
Then why can't I equate it to zero point 0.4, ma'am? Like, what is the difference?
you can do it. But you should get the same Kc value here.
Okay, ma'am. Okay.
Okay. If not, there is another chance. I need to get this Kc value, so just keep putting here. If I give, because I given you the alpha values already. So just keep inserting the alpha value and check which will give you 4 value here.
Got it, ma'am.
Hmm?
Yes, ma'am.
Yes.
Yes.
Yes, what's the name there?
Ma'am, is it A, ma'am? 3 carboxy, 3 hydroxy pentane dicarboxylic acid.
Whenever you are having the same functional group more than one time, even if it's 2 times, you have to give the parent and then you should talk about the functional groups. Now I can see there are 3 times of carboxylic acid here. I go for my parent 1, 2, 3. Now the second position I have OH group, so it is 2 hydroxy. And at what is it? Is a propane? Yes, it's a propane. At 1, 2, 3 position I have carboxylic acid. So it's tricarboxylic acid. Understood?
Got it, ma'am. Yes.
So what is your rule here? Whenever you're having the same functional group more than once also. You see, for example, I have CH2OH, CH2OH. Here, what do I say? 1, comma 2 dihydroxy propane, ethane it is. You can people see people writing ethane 1, comma 2 diol. Have you seen this?
Yes, ma'am.
Hmm.
Ma'am, I'm
Got
back,
it.
ma'am. Sorry, ma'am, for the interruption.
Okay, da. We are just discussing about this IUPAC nomenclature here. Whenever you're having the same functional group more than one time, choose a parent chain. Here my parent chain is 3 carbon system. At the second carbon, I also have hydroxy group. So I say it's 2 hydroxy propane And 1, 2, and 3 position, I have 3 carboxylic acid. So it is tricarboxylic acid. Understood?
Yes, ma'am.
And we did this problem here. H2 plus I2 gives 2HI here. They have given you the equilibrium concentrations of them. So once the equilibrium concentration is given, I can calculate the Kc value. They say if initially 1 mole of each was present, what is the alpha value here? So it is 1 minus x, 1 minus x is 2x here. So I write the Kc for this statement here, 2x power 2 because the coefficient is 2 divided by 1 minus x square because both are 1 here, which should be again equal to 4. So I am calculating what should be the x value from here. Understood, Mitul?
Yes, ma'am. Yes, ma'am.
This is direct conceptual question where you need to look for their electronic configurations here.
Yes, ma'am.
So
Ma'am,
this
you told that this doesn't have any for finding the configuration. We don't have any shortcuts, no, ma'am.
configuration you don't have any shortcuts.
Got it, ma'am.
Only shortcut is that you can go from the noble gas configuration.
Yes, ma'am.
It's after xenon here. So from xenon you can start writing the configuration and then find it. Okay, the answer is dyspromorphium here. So I suggest you whenever this kind of question from DNF is there, only if you know the proper electronic configuration, attend it. If not, don't attend it. Tell me which series will that element be? Dysprosium?
Ma'am, it comes under the lanthanoids, ma'am.
Lanthanoids, correct. Because it is after xenon. So it should be lanthanol. Yes, next question. You can see that the nucleophilic substitution reaction has happened, but the reactant is a unique one, thionyl chloride here. So we have learned thionyl chloride plus a base for nucleophilic substitution. Thionyl chloride without a base. Here the thionyl chloride is without a base. So whenever thionyl chloride is coming without a base, it goes for ipso substitution. That means retention of configuration. If thionyl chloride comes with a base, usually pyridine is a base or Et3N they can give you. Then in that case, the nucleophilic substitution will undergo Walden inversion, which is SN2 substitution reaction. So here it will be SNI, ipso substitution. Understood, Pa?
Yes, ma'am.
And by looking also, you can see there is a retention of configuration here, isn't it?
Yes, ma'am.